All right, welcome back to the channel, guys. If you have been supporting, thank you for that. Keep liking, keep sharing, keep commenting. All of that supports the channel, which I really need support. So today, what we're going to be looking at is the derivatives of the regular trigonometric functions. So I would have done a video on the inverse trigonometric functions. I hope you got a look at that. So we're going to look at the regular trigonometric functions, and we're going to take a similar approach where we list the regular trigonometric functions on this side. So f at x is going to be sine of x, cosine of x, tangent of x, cotangent of x, secant of x, and cosecant of x. All right. And then over here, we're just going to put f prime at x, because that's where we're going to put the derivatives. Now, just before we begin though, if you did not know before that these co-functions right here, all these co-functions are complements of the regular functions. Like they are regular functions, but for example, sine and cosine, they're complement of each other. Tan and cotangent, complement of each other, and secant and cosecant, complement of each other. And that's why I aligned them as how it is. Now, all the co-functions also, their derivatives are negative, right? So if you're doing a proof or you're taking the derivative of a cosine x or cot x or cosecant x and it's not negative, it means that somewhere in that working out, you did something wrong, all right? Now, we're going to start with the sine of x. Now, if you have been watching my videos, you would have seen where I would have proved or derived the derivative of sine of x is equal to cosine of x from first principles. So we're just going to write that down to start with, right? And then we follow through with the other. Now, to get to the derivative of the cosine of x, remember we talked about sine and cosine are complement of each other, and complementary angle sums to 90 degrees. So because that is true, this is a fact that cosine of x is equal to the sine of pi over 2 minus x, right? Right? So let's say x is 60 right here. The cos of 60 is the same as the sine of pi over 2 minus, I should be using radians, seeing that I already have the radians and not the degrees, but a lot of persons tend to understand degree measures than radians measures, right? Because if I say pi over 3, then probably that will be confusing. So pi over 2 in degrees is 90 degrees, right? So let's just write that in green at the top. It's 90 degrees. So for example, if I have the x being 60 degrees, right? So cos of 60 is the same as the sine of 90 minus 60, which would get you to 30, right? So sine 30 and cos of 60 is the same thing, right? So that's why this is true. Now, because it is true, and we already know the derivative of sine of x, we're going to use this right here to prove the derivative of cosine of x. So we're going to take the derivative of both sides. So it's d by dx of cosine of x is equal to d by dx of sine of pi over 2 minus x. And we're just going to be focusing on this side. We're leaving this side unchanged because this is what we want to show, that the derivative of cosine of x is equal to what we're going to get over that side. Now, if we're taking the derivative of this right here, we already know that the derivative of sine of x is cosine of x. We're going to use the chain rule right here. So the outside function is sine of x. So this is going to equal to, on this side, the cos of x, well, not the cos of x, the cos of pi over 2 minus x, right? And then we need to multiply that by the inside function right here, which is pi over 2 minus x. We know that pi over 2 is a constant. That's just 90 degrees in degree measures. So that's just going to be equal to 0. And when you take the derivative of negative x, you're just going to get negative 1, right? So that's just negative 1. So in reality, what we do have is negative cosine of pi over 2 minus x. And just the same, the cosine of pi over 2 minus x is equal to the sine of x. So this is equal to the negative sine of x. It is much simpler to write it like this than like this. And I think that is why they represent the derivative of cosine of x like this. Easy to remember. So it's just the negative of sine of x. So that's negative sine of x. Now let's move on to the tangent of x. So the tangent of x is equal to the sine of x over the cosine of x. That's the trig identity right here. Trig identity really helps with finding the derivative of trigonometric functions. And that is why when you're doing, for example, pre-calculus, you would look at trig identities, or even in calculus, you look at limits and all of those stuff. All right, so we know that tan is equal to sine over cosine. Now, where we see a quotient right here, we think of the quotient rule. So we're going to use the quotient rule to find the derivative of this right here. So I'm going to label them because that's what I always do. It's like a little habit, but it's fine. I'm going to label this u and label this v right here. And d by dx of tangent of x is going to be equal to, and I'm just going to get straight to the point. So we're going to take the square of the denominator right here. So it's cosine squared of x in the denominator. And right here, we're going to keep u, which is cosine of x, and we're going to differentiate v. When we differentiate sine of x, we get the cosine of x, so that's just cosine of x, just the same. And we're going to subtract. This time, we're going to keep v, which is the sine of x, and we're going to differentiate u. When you differentiate the cosine of x, you get the negative sine of x. So that's just times the negative sine of x, right? Let's bring the vinculum out a little bit further. Now, this is just equal to the cosine of x times the cosine of x. That's just the cosine squared of x. And I'm just going to take care of this negative sign immediately. That's negative times the negative. We get a positive right here. And then the sine of x times the sine of x gives you the sine squared of x. And we're dividing that by the cosine squared of x. Right? Now, in the numerator, what we have here is a trigonometric identity. The cosine squared of x plus the sine squared of x is just equal to 1. So we could rewrite this entire fraction right here as 1 over cosine squared of x. Now, we could leave it like this, but they don't leave it like that. What we would see that the tangent of x is equal to the secant squared of x. And this is how they got to the secant squared of x. We know that the cosine of x is equal to 1 over the secant of x. So because we know this, similarly, the secant of x is equal to 1 over the cosine of x. So we just swap those two. So we could rewrite this as the secant squared of x. And in that form, that is how it would be represented. So this is just equal to the secant squared of x. And that's for tangent of x. Let's move over to cotangent of x. Okay. Now, the cotangent of x is just the reciprocal of the tangent of x. So we know that tangent is sine over cosine. Cotangent is cosine over sine. And again, right here, we're going to use the quotient rule to find this derivative. So let that be u, let that be v, because that's how I do it. And we're going to take the derivative of both sides. So d by dx of cot x is equal to, I'm just going to draw the line just the same, because we're going to just take the derivative of that right away. So we square the denominator, that's sine squared of x. right? And we're going to keep u, that's sine of x, and we're going to differentiate v, cosine of x, that's negative sine of x. And we're subtracting, right? We keep u earlier, so we're going to keep v this time. And we're going to take the derivative of sine of x, which is cosine of x. And that's a multiplication sign in between. So in reality, what we do have is the sine of x times the negative sine of x will give you the negative sine squared of x. And we're subtracting cosine of x times cosine of x is cosine squared of x divided by the sine squared of x. Now, right here, what I'm going to do is I'm going to factor out the negative one right here because I want to get back to the previous identity where sine squared of x plus cos squared of x is equal to 1 to get rid of all of that in the numerator. So when we factor out negative 1 right here, what's inside the parentheses is sine squared of x plus cosine squared of x all over sine squared of x. So right here, as you can see, that's just equal to 1. And what we're left with is just negative 1 over sine squared of x. Now, we could leave it like that, but they don't in most cases. They write it for it to be a little bit simpler or look a little bit simpler. But we knew that it would be negative because all the cofunctions, the derivatives are going to be negative. But we know that the cosecant of x is equal to 1 over the sine of x. And similarly, the sine of x is equal to 1 over the cosecant of x, right? And because we know this right here, we can rewrite this as equal to, this is just equal to the negative cosecant squared of x. That's what we have, right? So we're going to go here and write that in purple. So that's negative cosecant squared of x, right? And you can see where it match up. The derivative of sine is cosine, derivative of cosecant. So it's sine, cosine, sine, secant, cosecant. So these should be opposite of each other similarly, I think. They are a complement of each other, but let's look at what the derivative bring in that case. All right. So the identities that I've been writing earlier, so we know that the secant of x is equal to 1 over the cosine of x. And because we know this fact, we're just going to take the derivative of this so we can know what the derivative of the secant of x is. So d by dx of secant of x is equal to d by dx of 1 over cos of x. And I could use the quotient rule here. This is a fraction. But what I'm going to do, I'm going to bring cosine of x up so we could use the chain rule. So we're focusing on this side. So this is just equal to d by dx of cosine of x all raised to the negative 1, right? This notation sometimes gets a little bit confusing, especially when you're just starting to learn this concept, because this is not inverse. This is an exponent right here raised to the negative 1. And you cannot write cos of x to the negative 1 as cos negative 1 to the x, right? You can't do that. Then that becomes very, very confusing. So most persons just use the arc cosine or arc sine or arc tangent when they have the inverse functions, but that's fine. But what we're going to do here, we're going to use the chain rule to differentiate this one. So this is just equal to, the outside function is an exponent right here. So we're going to take that down. Using the power rule, we take that down. We keep the inside function. We multiply that by cosine of x. And we need to subtract 1 from the power. -1, -1. I believe we get -2. and we need to multiply by the derivative of the inside function. The derivative of cosine x is negative sine of x. There we go. So now what I'm going to do is I'm going to rewrite this as a fraction because I want to remove the negative exponent right here. So this is just going to give me, let's get back to purple. This is going to equal to negative 1 over cos x all squared multiplied by negative sine of x. Now, we could leave it like that, but we can clean this up because we know trig identities that can simplify this product that we have right here. So what we are going to do is I'm going to rewrite this in a way where I could get it to be simplified using some trig identities. So here I have sine over cosine, so I know I could get tangent right there. And I would be left with 1 over cosine. So we're going to do that. But here we can take care of the negative also. Negative times a negative is going to be positive. So we could just get rid of these right here. We could just get rid of these and just work with what we have right here. I could split this up right here. Cosine cos x all squared. I could rewrite this as cos of x on this side and cos of x on that side, which is, it's the same, right? Because when you multiply these two fractions, you're going to get the sine of x over cosine squared of x. So recall that 1 over the cosine of x, 1 over cosine of x is secant of x. So this is going to be secant of x times sine over cosine is tangent of x. So we have tangent of x. So the derivative of secant of x is equal to secant x tangent of x. So we have secant of x tangent of x. There we go. So secant of x, tangent of x. And we're on to the final one. Let's go. And we know that the derivative of the cosecant will be negative because it's a cofunction. All right? So cosecant of x, we know that cosecant of x is equal to 1 over sine of x. That's an identity. And again, we're going to use the chain rule to prove this. So what I'm going to do here is write d by dx of cosecant of x is equal to d by dx of 1 over sine of x. Right? And I'm going to bring that sine of x up, and I'm going to do it in that space right there. So I'm going to erase this right here and write that sine of x raised to the negative 1. And then we're going to use a chain rule, right? So let's go. We're going to focus on that side. So this is going to be equal to, again, the outside function is an exponent right here. So we take that down. The power rule says we take that negative 1 down right here. We keep the inside function. And we subtract 1 from the power. When we subtract 1 from minus 1, we get to minus 2. And we're multiplying that by the derivative of the inside function. And the derivative of sine is cosine. Now, again, I'm going to remove the negative by representing that as a fraction. So this is just equal to negative 1 over the sine of x all squared times the cosine of x. And again, I can do the same thing here. In fact, we can't get rid of the negative because that doesn't cancel out. So we know that we're going to get a negative answer. So we're going to take the negative out front. This is just equal to negative. And I'm going to split this up right here. And I could do this in this space right here. I could split this sine squared of x to both denominators. So this is sine of x times sine of x. I could do that. As you can see here, we have the negative 1 over sine of x. 1 over sine of x is cosecant of x. So this is negative cosecant of x times cosine of x divided by sine of x. This is an identity and this is equal to cotangent of x. So cosecant of x times cotangent of x is what we have there. And that is the derivative of the cosecant of x, which is negative cosecant of x cot of x. And those or these are all the derivative of the regular trigonometric functions. Thank you for watching, and I really do hope that you take a look at my coming videos. All right.